Hi everyone and welcome to Angular 2 War Stories. Now, what we're going to talk about today is the lessons we've learnt building and teaching Angular 2. Now, when a lot of people come to a War Stories talk, what they're looking for is the things we didn't like about the framework or the things that we thought were different, but you're not going to get that from us today because we actually have loved working with Angular 2. The idea of today's talk is to tell you about the lessons we've learnt and to get you to know what the right questions to ask are and to come down on the right decisions. So I'm Adam Stephensen, I'm a solution architect at SSW, and I've been building Angular 2 and .NET Core since they were both in early beta, which has been lots and lots of fun. But the favourite part of my job is that I run Fire Bootcamp. And so we've actually just released a 6-week part-time online course on Angular 2, and I'm really loving taking students on the journey and taking them from older web technologies or from desktop technologies and get them using Angular 2 in production.
Cool. Hi everyone, my name's Duncan. I'm a software architect at SSW and I'm one of the mentors at Fire Bootcamp Online. And I've been pretty lucky over the last 2 years to almost solely do Angular 1 and 2. Been involved in about 12 apps that are in production over that time, and been really lucky with Stevo to travel around the country teaching Angular 2 to hundreds of other Aussies, all the way back to alpha versions of it about 10 months ago. And more recently got a chance to go over to Utah to go to NG Conf, which is like the biggest Angular conference in America, and travel around a little bit there with some of the teachers over there and help present at some of their workshops. So hopefully we can share some of that, knowledge from, teaching and shipping Angular 2 with you today.
Excellent. So what we're going to talk about today is we're going to talk about what is Angular 2 and why you should care. We're going to talk about frameworks and talk about Angular and React and how to upgrade. We're going to talk about get your head around module loaders and build systems. We're going to talk about TypeScript and why that's awesome and about the right IDEs to be using. We're going to talk about CSS frameworks and widgets, which is actually surprisingly complex. And then we're going to tackle observables, RxJS and Redux. And this is where the rubber really meets the road. And our goal there is to get you over the learning hump of getting through some of the toughest concepts that you need to get your head around in modern web development. So why should you care?
So before we jump into Angular 2, let's take a quick walk down memory lane and have a look at kind of the history of the web. And it all started in 1995 when Brendan Eich wrote JavaScript in 2 weeks, which is kind of crazy because it's now running the web and our servers. And in 2002, we got XHR requests from the Outlook team at Microsoft. And this was pretty cool because now we no longer had to do page refreshes. But you could kind of argue that Ajax and XHR requests didn't really get awesome until Google Maps came out in 2004, and people were kind of like had their heads blown off when they saw what you could do in the web. And then 2006, we saw jQuery come along. It was like the first time we saw Microsoft and Google and Apple all agree to use the same framework. And it was kind of about the same time we saw people start lighting a dumpster fire in our front ends and writing heaps of spaghetti code as well, which was an interesting time. 2008, we got the Chrome browser and the V8 engine. Things started getting faster, and people were getting more ambitious with what you could do in the front end. We got Node in 2009. We saw JavaScript on the back end, but more importantly, the front end got a package manager, the Node package manager, which is the predominant thing that a lot of us across lots of backends are using for our front end package manager. 2010, we saw Knockout for data binding, and now it's kind of been knocked out. And then we got Angular in 2010 as well, version 1. So it's now about 6 years old. So they've learnt a hell of a lot being the dominant front-end framework over the last 6 years, but it's definitely getting a bit dated. And for that reason, in 2013, we saw React kind of come on the scene. They were solving some of the problems with Angular 1 when it started to scale, got a bit slower, and has had a fair bit of traction. We got TypeScript in 2013, and that was only for the Microsoft guys. None of the cool kids thought it was cool until Angular 2 announced that they would be using it. Now they think it's brand new and it's really cool. And then this year we're seeing Angular 2 come out. And we're also seeing ECMAScript 6 become the de facto choice for the language. And that's the biggest upgrade to the language in 6 years, so it's huge. It's a big change. But what we're not seeing here is all the other stuff in JavaScript. We're not seeing all the different libraries that have kind of come up in the last couple of years. You've got System.js and React, Ember and Aurelia and Broccoli and Brunch and Webpack and so many things that it's coined this term JavaScript fatigue. And people are getting burnt out trying to keep up with the pace of all these new libraries. So it's a very interesting space at the moment. There's a lot of churn.
So Angular is a JavaScript framework, right? Well, it used to be. With Angular 1, the Google team described Angular as the superheroic JavaScript framework. Its goal was to be the best of the best JavaScript frameworks. But with Angular 2, they've got a lot more of a lofty goal. It's a development platform for building mobile, desktop, and web applications. So the goal is that you'll be able to build iOS, Android, OS X, Linux, and Windows apps, as well as web apps, all using Angular 2. But what was the major problem with Angular 1? Anyone? Speed, yeah. It was slow. If you're trying to build really big complex apps, or you're trying to get your app to run on a mobile device, you hit all sorts of performance issues. And that's been a key focus of the Angular team. So Angular 2 is super fast. It's got optimized code generation. Your HTML templates are turned into highly optimized code. We've got Universal, which renders your initial view on the server side. So it's downloaded just in HTML and CSS into the browser, and you get great SEO. We've got code splitting, so you're not downloading the whole app the first time you hit the first page. You're just downloading it in chunks as you navigate throughout your application. The reason I love Angular 2, though, and that my teams love it, is it's massively productive. So the component model makes composing applications really easy. We've got the template syntax, which is really simple and powerful. We've got TypeScript, which gives us strong type for our JavaScript. And the Angular CLI, which it does code generation, which is great, but what we love about it is it makes our build process much, much, much more simple. The big thing about Angular compared to some of the other frameworks like React is it's actually a complete framework. So it gives us nearly everything we need right out of the box, rather than having to go and choose a whole lot of other libraries and bring them in. So it includes routing, testing, internationalization, animations, accessibility, and it's a production build tool with the CLI. So Angular is the most popular framework. What we're looking at here is a graph of Google Trends on search word key history for the top Angular frameworks. So down the bottom, you can see Ember, Aurelia, and Backbone, and they're really, they're much less popular than something like React. So you can see that React's much more popular, and Angular's much more popular again. Now, why is popularity a big deal? And when you're talking about frameworks, well, the more popular frameworks are going to have more community involvement. There's more blogs, there's more libraries to support them, and you know that they're going to be around longer because there's a bigger community behind them. So, and that's a big deal. How long is your framework going to last?
So this is not so much a 101 talk today, but we're going to have a quick look at what makes up Angular 1, and then we're going to jump into the areas that we found are the most tough shipping Angular 1 and people have had the most trouble learning. So to kind of have a brief look at what is Angular architecture, and in particular its component architecture, I'm just going to run you through that quickly. So it all starts with a component. So a component is where we put the logic that's going to drive our HTML views. And on top of these components, we put on metadata. And this metadata lets Angular know that this is an Angular component. But this metadata also does some other things. And one of those things is that it glues together this component with a HTML template. And when you take this structure here, you could say that it's a module, and you're able to export this module and then import it into other parts of your application and reuse it. And this is a pretty big deal because then that's how you can reuse components across your application. So if you've got properties on your component in your component logic and you want to share them with your HTML template, then you'd be using property binding. And then if you've got events that are being raised in your HTML template and you want to communicate those back down into your component, then you've got event binding. And then we might want to insert other components so we can reuse them, so we can do that as well, or other directives. And we might also have some reusable logic that we want to share across our application, so we can put those in services. And then we can use Angular's dependency injection system to inject those services into our component. So this is kind of the core parts of component architecture. And we call this the beauty of Angular 2 architecture. And we've got some pictures of this in our books we'll talk about later. So once you have one component, and then you've got 2 components, 3 components, or hundreds of components, and it starts to build up, you end up with this component tree. And it's an important thing to understand with Angular 2. It's a big difference. So imagine at the top of this tree, we have an app component, and this is where we put all of our initialization logic for Angular 2. And then underneath this, for example, we might have a to-do component shown here in red, and also red in the browser here. And all this component does is just be the parent for 2 other children component that I'll show you in a second, and it just puts this title on the page. So underneath here, it might be the parent for a child component that we call the to-do list component, shown in green. And all that does is just render out a list of to-dos. And then we might have another component, and it just has a simple task of being an input field, and it can capture another to-do and add it into that list. So you end up with all of these different components that you can reuse everywhere in trees. And this becomes important because it makes communicating between these reusable components much easier. It allows us to be able to do much faster change detection with strategies like onPush, which we'll talk about later. And also, it allows us to do advanced routing. We're able to do things like code splitting that Steve-O mentioned before. So Angular 2 itself is pretty easy. I never hear people complain saying, data binding or making components or doing routing or doing dependency injection and services are complicated. But Angular 2 makes you confront modern web development. It makes you look it in the face, and there's a bunch of stuff you've got to learn. So some of these things you're going to have to learn as TypeScript. You're going to have to learn to do a bit of reactive programming. You're going to have to understand RxJS. And you're going to have a pretty good understanding of modules and module loading and module bundlers and all of those sorts of things that come with ECMAScript modules. And Angular 2 really embraces modules. It's one of the first frameworks to really embrace it. And we're going to cover a whole stack of this stuff today. So in summary, when we're talking about Angular and why you should care, we think this component model is a big deal because of the whole composability. We think it is very fast, and this whole cross-platform story is a big deal. We think you're going to be much more productive. It's much easier to learn, and it's actually a real joy to use. And we think you're going to write better applications. We think you're going to be much more ambitious with what you're going to try and write with these modern frameworks.
Cool. Excellent. So let's talk about framework choice. So it's a big decision choosing what framework you're going to use for your next project on your team. The decision you make is going to affect your team and what you're doing for the next couple of years, but it's even a bigger decision than that. When you're choosing a framework for your team, you're actually making a career choice. And this is what you're going to be a specialist in. So you've got to choose a framework, and this decision is going to affect you for a long time. So really out there, we've got three choices: Angular 1, React, and Angular 2. Now, should you use Angular 1 on new projects today? Well, we think you should only use Angular 1 if you already know it and you've got an urgent deadline. Why is that? Every line of Angular 1 you write today is technical debt. So if you think about it, if you spend the next 6 months writing Angular 1 code, that's 6 months of Angular 1 code that at some point you've got to upgrade into modern web technologies. So that's a really big deal. But what about if you've already got an Angular 1 project? Well, most people think there's two approaches. They can either rewrite or they can do an upgrade. Now, you can actually put Angular 1 and Angular 2 in the same project using the upgrade adapter. Now, while this sounds like a great idea, we don't think you should do it. So it does let you start writing Angular 2 today, but it's a huge refactor. You've got to change your application significantly. And there's a big performance cost because now you're actually downloading the Angular 1 framework and the Angular 2 framework. And you've got a big learning curve. What we think is a much better idea for projects that are doing an upgrade is to start writing your Angular 1 like it's Angular 2. So you're going to introduce a module loader. You're going to start writing TypeScript. And what a lot of people get wrong is you don't have to change your whole project to TypeScript. You can just, for the next JavaScript file you make, you can just do that in TypeScript and start writing TypeScript in your application. And you can start writing Angular 1.5 components. Now, the benefit of that is it's low risk. You're learning Angular 2 concepts as you go along, and it's a faster path down the track when you do rewrite. The downside, of course, is that you are actually still writing Angular 1. Now, when people do, there's a lot of people out there at the moment going to their bosses and saying, I need approval to rewrite our application. And what they're talking about doing is doing a big bang rewrite. We're going to take our current application and we're going to maintain it, but we're actually going to go and rewrite the same functionality from file new project in Angular 2. And that sounds fun, and you end up with a nice clean project. But obviously there's some downsides. It's high risk. You're maintaining an existing code base while you're embarking on a 12 or 18-month project to go and rewrite it again. And all you're doing is recreating the problem. The boss doesn't want to approve it because he knows in 4 or 5 years you're going to come and ask for another big approval to go and do exactly the same thing again. So what we think you should be doing is rewriting your apps into smaller applications. So what we want to do is we want to say, well, we've got this new module we want to write. Let's extract some common shared functionality like authentication, and then we'll keep our existing Angular 1 app, and we'll just start writing Angular 2 in new, smaller applications that we'll stitch together. Now, so what this does is it lets you start writing Angular 2 today. It's much easier to get approval for it, and you're not perpetuating the problem. There's no more big bang rewrites. The downside, of course, is that there's DevOps overhead. Okay, so you've got a little bit more complexity, but we think it's definitely worth it in the long run.
And this has actually been a really interesting experience for me. The last 4 Angular applications I wrote are all smaller applications that are all deployed separately, all styled to look exactly the same, but they come together to form a bigger application. And they definitely had some DevOps overhead, and they had to write another authentication service. They could use tokens to be able to manage all that. But they're in this prime position now where they can start writing a 5th part to this application, and it's just going to be a greenfield project, and they're going to do it in Angular 2, and they don't have any rewrite overhead or big bang or any upgrade strategies. They're just going to be able to just go off and cut their teeth doing Angular 2 in a greenfield, which is kind of, you know, a bit of a mental shift in the way that we've done it in the past. So if you're kind of sitting here now kind of you know, I'm thinking about what it looks like to upgrade my project, or I'm thinking about what the migration strategy is, you probably should also throw into that mix of kind of starting to think, you know, maybe I should start also considering the way we architect our applications. Is there a chance here that we can start thinking of some different strategies so we're not looking at such a big amount of energy just so we can start moving our existing code?
So in summary, writing Angular 1 is creating technical debt. And if you are going to upgrade, it's 3 times the effort to migrate slowly, but it's much safer. And what you should be doing is consider rewriting your application into several smaller applications. Now, we get asked a lot, I'm about to start a new project, should I do Angular 2 or should I do React? Now, as the chief architect of SSW, Adam Kogan, will say, he'll say, we most commonly use Angular 2 today, but both are going to get you there. We're not here to start a fight between Angular 2 and React. They're both good frameworks, but let's have a look at some of the differences. So in React, it uses JSX. So you take your HTML and you actually embed it into your JavaScript component. Some people like it, but personally it doesn't feel right for me. React is only a library, so when you're building a React project, you go out and you choose a different routing. You go and get another library to do routing. You go and get another library to do animation. So React is just a library. It's not a full framework. React introduced the Redux pattern, which we love, and that really simplifies complex state management. So we love that they've introduced that and popularized that, and it's backed by Facebook. Angular 2, on the other hand, has separate HTML components. Has separate HTML templates and JavaScript components. It's a complete framework, so you get nearly everything you need right out of the box. It uses TypeScript for strongly typing your JavaScript, which makes refactoring easy and gives you compile time checking. It's got a larger community, which we can see is already getting massively popular and already generating massive amounts of content. And it's backed by Google and Microsoft. So why do we use Angular 2 at SSW? Well, we choose Angular because our clients are comfortable with Angular. We've been building on Angular since it was in beta, and we had government and really large enterprises coming to us going, we know it's in beta, but we want you to start these projects for us. Because they've used Angular for years. They're comfortable with the brand and they trust that it's the way going forward. You get less churn. Because JavaScript is a full framework, it's not a library that then you need to go and choose other libraries on. It means that what you're doing in Angular today is going to be very similar to what's doing in Angular next year or the year after. Your devs aren't getting JavaScript fatigue from constantly needing to update to the latest routing, latest routing library, for example. And it lets our teams focus on delivering business value. They're not constantly checking out these latest things. What they're focusing on is actually just using the tool to actually deliver value to our customers. So this is one of the other really common questions we asked. When's it going to be ready? Well, Angular 2 is ready now. We're building really large government projects on it, really large enterprise customers, clients on it. The only thing we're waiting on is the offline compiler. And the offline compiler is a big deal. You know, it's a big deal for being able to bundle your application for production. But even for that, we're only waiting, like it's right around the corner. So in summary, Angular 2 is ready now. Both Angular 2 and React will get you there, but we like Angular 2 for our enterprise apps.
So let's talk a little bit about modules and build systems, because this is a pretty big part of Angular 2, and it's something that takes a while to kind of start thinking down this road. So one of the problems we had with Angular 1 is that we had to do this initial download of the entire application. We had to kind of get the entire thing down for initial load. We couldn't do it in parts. And for that reason, we had these time-consuming build systems. We had several hundred lines of gulp to try and crush down the size of our initial downloads so we could get them smaller. But we still had pretty slow loads, and not uncommon for some of our larger applications to take 5 seconds on that initial load. And this is where modules and the new ECMAScript 6 module syntax and module loaders and module bundling can really help us, because not only can it help us optimize bundling down into a smaller package, it can help us make multiple packages so that we can just ship down what we need for the home page, and then we route to another section, then we can download what we need for that other section. So that's called code splitting, and it's a pretty big deal for what's coming in Angular 2. So JavaScript was pretty simple before, but now it's not so simple, a lot of these front-end frameworks. It's not just Angular 2, and you have to have a build system now pretty much. And if I wanted to do a hello world in Angular 1, I could do this. I could just have the Angular library as a single JavaScript file, an index page, and then I was off. And I mean, this is not an enterprise application, but that's all I needed. If I wanted to do the simplest thing right now to get started with Angular 2, I would use the CLI, and I'll download this. And it's only 350 megabytes and 48,000 files. And most of that you're not going to put in the browser. It's in your node modules, and Steve-O's going to talk about that. But it's a different world that we're in right now. And this whole module loading is kind of a big part of it. And if you haven't used Aurelia with JSPM, or you haven't used React with a module bundle, or you haven't used Angular 2 with a module bundle, you probably don't know that you don't know that module bundling is a thing, and that you don't just put a script tag on your index page, and you're in for a context shift in the way that you think and build your applications. It's getting a bit trickier. So what are all this module stuff we're talking about? What is it? So an ECMAScript 6 syntax for the module would look something like this. Imagine I have a math file, and inside of there I've just got one function. It's called a sum function. It just adds two values together. But it's got this export statement. So I can export this out of this file, and I could import it into another file using an import statement like this. So I've got a calculator file, and inside of there I'm using this special syntax to say import sum from math, and then I've got availability of that. This is not rocket science, but what you can do with it is pretty cool, because now we're saying I've got these files and I know everything about my application. I know everything that's going in, I know everything that's going out with these imports and exports, and I can start to form like a dependency graph. And then we can start to do some cool stuff. So imagine I've got this JavaScript file, or a TypeScript file it could be, and I'm importing into that another TypeScript file and another TypeScript file and a Sass file. And then one of those other files is importing a CSS file, and so on until your application looks really big and messy. And then you've got this dependency graph. But you know everything that's happening. It's no longer just a script tag on your main HTML page. You've kind of got this understanding. So you can pass that to a module bundler like Webpack or the System.js builder, and it can bundle it for you in a much smarter way into a small bundle of assets. And you could do just one bundle for your whole application, or you could start to split that into multiple bundles, and then this is how you can achieve code splitting, where you download just what you need for each section of your app into the browser at one time. But we've kind of got a couple of things that need to come along for Angular for this to happen. We've kind of got a couple of challenges. In Angular 2 at the moment, we do what's called dynamic mode. So we're actually compiling our templates in the browser. So who can help me out here in the audience? What do you think's the downside of compiling in the browser? It's going to be slow, yeah. Not only do we have to download this compiler, we also have to wait for it to do its compilation. So this is where this offline compiler that's coming is a really big deal. It's like the last big thing for them to say, we're at version 1 and it's RTM and everybody's a green light. So in Angular 1, it currently runs in the browser. We make an XHR request, we get a HTML file, and then we parse that in the browser, and we kind of cross-check that with our JavaScript, and we make some DOM, and then we've got executable Angular code. So that's what's currently happening. But this is not so good because we can't run it on the server, and we can't run it in a web worker and a bunch of other stuff. So this offline compiler, the way it will work, we get that same HTML template, but now we're going to parse it on our server with Node. So this is a command line tool that you can use, kind of like the TypeScript compiler. If you've used that, you go TSC in the command line, you can use it. This one will be NGC and you can use it. So once we've done that, we'll have this abstract syntax tree, and we have this executable JavaScript, and it's all been done on the server. So we just have to pass that JavaScript straight down. Nothing needs to happen. We don't need to get that compiler down there as well. So we're at much smaller downloads, much faster execution, and then we've got Angular 2 ready to go in the browser. So this is great, and we've got this offline compilation, but there's a lot more to it for building your applications with Angular 2 now. So we've also got inlining modules, we've got tree shaking, we've got minification. And this tree shaking is a pretty cool idea. So basically, it's just removing your dead code. So if you've got if you're using only half of the Angular 2 library and there's things in it you're not using, then you can tree shake those out and remove that code that you're not using, so you have less to download to the browser.
Cool. So what Duncan's saying is that for our build process, it's getting really complicated. So when we actually are packaging up our application, we need to copy fonts, we need to compress images, we need to lint our TypeScript, we need to compile our lesson Sass into CSS, we need to compile our TypeScript into JavaScript, we need to minify it, bundle it, then we need to run our unit tests and end-to-end tests. And now we need to actually run the offline compiler, do some tree shaking, and then build our app into separate bundles. Holy moly. It's getting really complicated and time-consuming to roll your own build process. I've got a bunch of war stories about this. So when we started Angular 2, we were building and bundling it like we did Angular 1. We were writing 700-line gulp files. Who's done a 700-line gulp file? Yeah, it's not fun. So there's heaps of things that we were doing wrong here. And we hear them all around the place. One of the complicating factors is, as Duncan showed, is that File New Project in Angular 2 has 50,000 files in it. And that's because you're downloading all of your dependencies into your Node Modules folder. And then for on our test server, we're just copying that Node Modules folder across, and that worked fine. But then when we shipped it to production, we thought, is this really right? No. So what we did was we created another file, and we included in that file just the files that needed to be copied to production when we deployed the Node Modules folder. And I know there's some of you out there in the audience going, you idiot, why didn't you just use Webpack? And we'll come to that in a bit. But what we didn't get is that we didn't have a good understanding of modules, because you can't just copy angular.min.js to your production server anymore. Angular.min.js is going to import 5 modules, and each of those 5 modules might import another 10 modules. So you can use a gulp file and use the system.js builder, but you need to understand module loading, and your build process needs a module bundler. So you can go along and you can get it working using gulp, but it's a lot of manual work. So a lot of people were telling us, go and check out Webpack. That's going to solve your problem. But there's a lot of work involved in Webpack. Who uses Webpack? Yeah, Webpack's powerful, but you've still got to roll your own build process. And in most companies, can I see how many of those guys are Oregon? How many have we got out there? Yeah, quite a few. Look, a lot of companies actually say, it's so involved, we want you to specialize in it. You're the Webpack guy, and you're going to be responsible for the build. Now, being the Webpack guy isn't the coolest job in the world, but hey, you're still heaps cooler than the Crystal Reports guy. And then the Angular, so what we're all really super excited about is the Angular CLI. And the Angular CLI also has this ability to bundle our app for production. But, so there's been this whole contention, Webpack or the Angular CLI, what's the go? Well, we've told you, don't use gulp, because modern tooling is going to save you a lot of work, and it's not recommended unless you've already got a big investment in it. Webpack's powerful. Webpack 2 is coming and includes great things like tree shaking, but it's complex, and you need to bring in the Webpack guy. And if you're already using it, we think you should stick with it. Really, the choice has been Angular CLI or Webpack. But the great news is that the next version of the Angular CLI is actually going to be using Webpack. So you no longer have to make the either-or decision, which we think is great. So let's talk about the Angular CLI. What is this thing I'm talking about? Well, you can use it. It's a command line interface that you can use to create your application. You can use it for code generation. It'll make routes, services, pipes, and components. It's made in conjunction. It follows it's made in lockstep with the Angular style guide. Okay, so it implements all of the best practices, and it makes scaffolding running your unit tests and end-to-end tests super easy. But the thing we love it for most is the great way that it can build our application for production. So this is what building and bundling an application using the Angular CLI looks like. We can jump out to a terminal and we can type ng space new space CLI demo. So that's the CLI command to create a new project, and we're going to call it CLI demo. We run that, it goes through and creates the files for our application. Then it goes out and it starts downloading all of the dependencies from Node Package Manager. Now I go in, I'm just going to change into that folder, cd space CLI demo. And then now to run that up and actually run that application, I can just go ng space serve. It's going to serve it on port 4200. I can open that up in my browser, and I've got a running Hello World Angular 2 application following all of the best practices. Pretty cool? But now I've actually got to go and write some code. So let's say I want to go and create a to-do component. You can see here I've opened the application up in Visual Studio Code. Now I can jump out to the command line and I can just go ng space generate, and I tell it I want to generate a component, and I'm going to call that component to do. So I'm going to do ng space generate space component space to do. Now what that's going to do is that's going to generate the files that I need to actually create a to-do component. So it's generated the HTML, CSS, the components TypeScript file, and file for generating the unit tests. So I can actually go in and have a look at, in the source folder, which is where we put our code, you can see that it's put that into our application for us. Now, if I wanted to build my application, I can just go ng space build, and that's going to build my app. Pretty easy, hey? So we've got guys who are using this for our enterprise clients right now. So I can have a look, and you can see now I've built it. I can go up, and before I was looking at my code in the source folder, I can go in here and I can see in the dist folder, it's actually taken my TypeScript and compiled it to JavaScript, and it's generated my map files. Because the dist is the folder that I can deploy out to the server, out to my different environments. But what I'm really interested in doing is I want to do all of those extra build tasks I need to do to get my app into production. I want to do the minification, I want to do all of those extra tasks, and all I need to do with the CLI to do that is to call ng space build again and pass it the -- prod parameter. So it goes through, it bundles it, it gives me the statistics on how big my output is, and now when I go and I have a look at my dist folder of what I'm going to distribute to my servers, you can see that all of the JavaScript files, so the map files have been removed, the JavaScript files have all been optimized and minified, and now they're in main.js. Pretty awesome. What's even cooler is once the offline compiler drops, you won't even see HTML files underneath the to-do folder, because even those HTML files are going to be compiled into highly optimized JavaScript and bundled in as well. So you can see the difference between the production build on the left, where it's all minified and it's all ready to go straight to our production server, and the one on the right is what we might deploy out to our test server so we can get easy debugging. So that's a lot of power from the Angular CLI. We love it because it follows the style guide. It updates with Angular, so as Angular's updated, the CLI updates. It gives us offline compilation really easily. It's a community project, but it's actually being led by the Angular team. And it means that our devs spend more time actually building and less time configuring and doing plumbing. There's a few catches. It is still in beta. It doesn't have full-time staff like Angular Material does. and it dictates your architecture and naming convention. So it's highly opinionated. And I like it because it's very verbose naming. They've got very strong opinions about, how you structure your folders, and you have to follow all of that. And there's, always people have opinions about these things, but we think it's amazing, and we think you should definitely be checking it out. So in summary, if you've got an existing build system, you should stick with it. Use the CLI for your new projects, and watch the CLI for Webpack and the offline compiler.
So let's have a quick talk about TypeScript and IDEs, because it's another big part of Angular 2. So one of the challenges of writing really large JavaScript applications is that the code bases become unmaintainable. If you've got hundreds of thousands of lines of JavaScript, or you're like the Azure portal and you've got millions of lines, then this can become quite difficult to refactor because you've got no type checking, and then it becomes risky. If you want to have to rename a variable across maybe 100 files, you don't really want to be the person who has to do that because you've not got a perfect assurance that you're changing a string and that's actually caught the right spot. So this is where TypeScript come along and helps out a lot. And TypeScript's going to be the default thing for Angular 2 as the language of choice. Now, I'm not going to go into TypeScript in detail here. If you haven't seen it before, I highly recommend you check it out. But what I'm saying here is there's a choice. That the Angular team are trying to give you a choice between TypeScript, but you can also use a couple of other things. You can just use vanilla JavaScript, be it ES5, the last generation, or the current generation of JavaScript, or you could be using Dart, but I still, to this day, haven't met a single developer who doesn't work at Google who uses Dart. So we're not going to talk about that one. We're just going to talk about normal JavaScript and TypeScript. So the TypeScript is going to give you this strong typing. It gives you amazing refactoring and amazing tooling. But another big part of it is the choice behind it is Angular 2 is actually being written in TypeScript. So it's kind of you can see there's a lot of greens on the left, there's not many reds on the right. It's pretty much everybody's using it. I haven't seen a single application in Angular 2 at the moment that's in kind of development mode or has been deployed that has used JavaScript yet. I've only seen TypeScript. I haven't seen anyone pull it off doing the other. Supposedly it's the aim that you can be able to do all these things, but I haven't seen it yet. All the docs, all the third-party libraries, everything else is in TypeScript. So you're going to be fighting an uphill battle if you want to go against it. And implementing the last generation of JavaScript, if you want to use ES5, might sound kind of cool, but it's not. The framework's totally not designed to use it like that. It's built with using the next generation of JavaScript in mind. So using decorators and other language features will be super verbose. Why not use it? I can't really come up with too many strong points. There's definitely maybe some fringe cases. Maybe you want to, you're right on that 1% to 2% of, fringe people who want to use a different compiler. You want to use language features that are coming out in like a couple of years' time, and you want to use Babel as your compiler maybe. But really, you're going to be fighting an uphill battle. So there's not much really here to say, but most people at the moment are using TypeScript. But one of the actual surprising war stories is choosing an IDE. So there's four main choices. We'll talk through these. So one of them is Visual Studio Code, which comes from Microsoft. So one of its big benefits is that it's got amazing TypeScript support straight out of the box. And it's kind of halfway between an editor and an IDE. It's more fast and lightweight. It's getting a lot of popularity. Atom's another one, fast, lightweight. You can get a plugin to use the TypeScript in it. It's pretty popular for Angular 2 as well. Now, to my surprise, Visual Studio is not very popular at all for Angular 2. I've done some development for Angular 2 in it. I didn't find it too bad. There's a bunch of extra config you can do to make the TypeScript stop complaining. But a lot of people, actually every person I know who does it as a day job with Angular 2 has said that they don't want to use Visual Studio for their Angular code, and they're using another editor for their front end and Visual Studio proper 2015 for their back end. And you think that would be a lot of overhead, but it's actually not too bad to do two different IDEs. So that's kind of surprising. And there's a team that we're involved with down in Canberra. They're building this really awesome 34-inch, this application designed for a 34-inch monitor in Angular 2. And they've got 3 front-end teams, and they mandated they all use Visual Studio as their IDE, being a nice government project. And they just loosened that up and said they can use other things, but they've been screaming for ages that they just want to get out of Visual Studio. I'm surprised. It'll come around, but right now, it's not so fun. So the other one's WebStorm, which has these really cool features, like things like import statements. So you're always writing import statements with Angular 2. You have to go import this from this and import that from that. And you end up with like 10 import statements or even 20 or more in some things. So WebStorm has this ability, if you're just saying a variable and you haven't imported it, you can click on it and it'll go input the import statement for you. It's pretty crazy. And then there's other features, so you can write HTML for your inline templates inside your TypeScript file, which I think is really cool. I wish I had it in Visual Studio Code. So there's some really cool stuff in WebStorm that you don't get in the others, but I don't really like big bloated IDEs, so I don't like the ones on the right. I tend to like Visual Studio Code, maybe I'm a tiny bit slower writing import statements. But there's a lot of personal preference here, but watch out if you're using Visual Studio at the moment. So in summary for TypeScript and IDEs, it's not a big story here. I think at the moment you want to be using TypeScript and keep your IDE that you're using for your backend, but make sure you're using one that's got great support for TypeScript on the front end and works well with Angular 2 and doesn't give you too many red squigglies and lots of config. So another surprising thing is CSS frameworks and widgets is a real pain in the butt right now. If you want to build a really good UI, you have a pretty strong dependency on a component library, either a third-party one or one you roll your own. But I don't really ever want to roll my own because I want to write value for my customers. So having a good component library is something we're used to. None of us right now would probably have any trouble getting a good date picker. But if you've got an Angular 2 project, you might actually realize that it is a bit of a trouble finding a good date picker that styles really easy because it's early days for a lot of the components. And the other thing is 6 months down the road of writing an Angular 2 project, it's not going to be easy to strip out your component library and stick in another one. So it's only a temporary thing for a lot of people right now with Angular 2, but it's a bit of a challenge, and it comes up almost every single person I talk to who's doing Angular 2 at the moment. So you don't want to have to pull out your library in 6 months or 12 months of development into an Angular 2 project and put in another UI library. So you kind of got two big choices or two big paths that you can walk down. One is Material 2. So this is built by the Angular team. It's material design specifications, and it's all about getting really good components. It's not just the look and feel. It's about having material components built for Angular 2. And then the other choice is Bootstrap. It's been, the dominant way of doing and styling your website since 2011. I'm sure a lot of you have used it and seen it, and we're all really used to it, and it's pretty awesome. So these are your two paths, but they don't work too well together. So there's lots of libraries coming out at the moment. There's PrimeNG, there's Widgemo, there's Kendo UI, which will be ready September-ish. We've used a lot of that with Angular 1. There's Semantic UI, there's Angular Material that I just mentioned. There's materialized conversions into Angular 2. There's Vaden components who do Polymer components that you can use in Angular 2. There's ng2 Bootstrap, there's ng Bootstrap, there's Fuel UI, and there's ng Lightning. So what I'm trying to paint the picture here at the moment is there's heaps of people pouring truck tons of investment into this because they all got benefits from Angular 1. And all of these libraries will be amazing with Angular 2, but right now it sucks because none of them are finished. And you're going to kind of build yourself into a dependency on some of these. So we're kind of looking, there's these two directions. So why would you want to go down the Material 2 path? The Material 2 path we think is going to be the default. Material 1 at the moment is super popular for Angular 1, and we think it's going to become the default for Angular 2. There's full-time Angular team members who are working on this project. It's not a community project, even though there's community contributions. There's heaps of energy behind it. It keeps pace with Angular 2. So this offline compiler, they've already got commits. They're ready for it. They're going to be one of the first people that will integrate with it. And there's first-class integration with Angular. It's built for Angular 2, not for Angular 1, not for any other library, just for Angular 2. But it's definitely a fork in the road. You can go left or you can go right with this decision with Bootstrap or Material 2, because as soon as you put bootstrap.css on your page, it conflicts and it won't work. I've watched some of our students, we've got them doing a task to build out a Material 2 application, and then they kind of extend it and they bring in Bootstrap and the whole thing blows up and they thought it was their code, but it's just the CSS. They don't play well together. It didn't in Material 1, it probably won't in Material 2 either in the end. So I'm talking about the components here, not just making it look like Material. And it's far from complete. It's in alpha, so there's no drop-down even. There's no date picker. I always pick on date pickers. It's the first thing I look for. So it's really early days. If you go down the Bootstrap path, it's really it's proven that you already saw there's lots of people who are going to be supporting that. The styling is going to be easier. There's going to be lots of third-party component libraries for it. And there's also going to be non-Angular libraries, if that makes sense. So we currently have a project we're building in Angular 2, and the client's really used to getting Kendo grids. We might not be happy making them, but they really want them. So they've got these Kendo grids, and we want to be able to do that, but there's no Angular 2 components for it. It's an Angular 2 project, so we're just using their JavaScript version, their raw bindings with JavaScript, rather than having Angular directives for it just yet. And that's working fine, but it's not as nice as having something that's built to work with Angular's binding syntax. And it doesn't work with Material, so you're not going to be able to go turn around and start implementing Material 2 components. And you're probably going to have a dependency on one of these two or both of them, jQuery and Bootstrap CSS. And you also got to watch out a little bit. This offline compiler, when it ships in the next couple of weeks, is going to change your build chain. And if you want to be able to use it, not all of these third-party component libraries are going to be up to speed just yet. So there might be a small lag before they're ready for you to use the offline compiler as well. So it might hold you back for a minute. So in summary for CSS frameworks, well, we're going to go on the left side here. We're going to say that we're going to start using Material 2. And we're going to pay a heavy cost for it because there's a whole bunch of components are missing. So we're going to go and find those other components. And we'll probably need to go to a couple of spots and style them up so they work in here. And we're going to pull them out as Material 2 puts them in. So this is a more ambitious way of going. We're going to pay the cost up front so we don't have to pay the cost later. But it's not a black and white decision, and going down the Bootstrap path and using another vendor is a totally suitable way of going as well. But this is what we're going to do on the next projects.
Awesome. Now, this is the part that hurts people. Who's doing observables in RxJS in their Angular 2 applications? Who had some pain? Yeah. This is the area where bringing teams onto Angular 2 and teaching students that they really, really struggle. Oh, I have to grab yours. Feels a bit like this, And why is that? Like, why is it such a big deal? Well, modern web apps are composed of asynchronous events, and async code can be hard to write, hard to refactor, and hard to debug. We deal with race conditions. Exception handling is hard. There's all sorts of things that go wrong when we're writing async code. But the whole goal of reactive programming is to simplify async code. And RxJS is the JavaScript implementation of reactive programming. Now, RxJS is baked into Angular 2. If you're going to do Angular 2, you need to know RxJS. It's used when you're doing forms. It's used when you're making a HTTP request. And a lot of people don't spend enough time getting their head around it, and they find that it comes back and it causes them a lot of pain. So my goal here is just to get you over the learning hump. Now, according to the definition, reactive programming is about applying the observer pattern to streams. So that's what I'm going to that's what I'm going to start off with. I'm going to explain the observer pattern, and we're going to talk about streams. So the observer pattern says this. Let's create an observable. And we might make this a particular observable of type person. And what we want to do is, instead of polling that person for changes, we want to be notified when particular things on that observable change. So what we do is we go and create an observer, okay? And we say, this observer is going to watch the name property on this observable. And whenever that name property changes, an event's going to be emitted that tells us, hey, the name changed, and now it says John Smith. Now, one thing a lot of people miss is you can actually have more than one observer. So I could create an observer for mood, for John, and I could create an observer on the shirt color for this observable. Another thing that people miss is that if you don't have an observer for a particular property, it's not being observed. So we don't have an observer around John's weight, for example. So he could go and lose a whole heap of weight and no one would notice. Poor John. Now, let's say I took my observable and let's say that I had an array. Now, what we can do in observers is we can actually apply different functions. So let's say my observable was an array. I can go and apply a count function, and the value that's going to be emitted is the value 4 on the array that I have of 1, 4, 7, and 9. I could apply a filter and say, just give me the values that are greater than 5. So I'm getting 7 and 9. And I can also chain these operations together. So I can chain a where operation with a count operation, which, because there's 2 values greater than 5, that's what would be emitted. Now, what happens when my observable changes is that then that observer will emit a new value. Cool? So we've talked about the observable. We've talked about observables. Let's talk about streams. Imagine that I had my array, but instead of actually having an array, imagine I was just drip-fed my array. Imagine that I was given each of those numbers in my array as someone clicked a key press on a calculator UI. So instead of having that array up front, imagine that I get the number 1, and then my operation's applied. And then I get the number 4, doesn't meet my filter, so nothing happens. When I get the number 7, I'm in my stream of numbers that are being emitted, I'm applying my operation, and what I'm getting out is a new immutable stream. So I've got one stream of values coming in, I'm applying an operation, and then I've got another stream of numbers coming out. Now the cool thing, so that can continue on, but the cool thing about streams is I can chain them together. So I can have these values coming in, I can be applying one operation, then I can go and apply another operation, and I've got another stream of numbers coming out. So the canonical example of this is the type ahead. And this is a great example of where RxJS makes the code much simpler to work with. So what I've got here is I've got the search text field, and we've got a search text field that we want to use as a type ahead. Now, we can get the value changes observable from the text field. Now, we can use the debounce operator to only emit a new value after 500 seconds of inactivity. Then what we can do is call distinct until changed to only emit the next field value if the value did actually change. Then we can use switch map to map the text field values into a new observable of HTTP search requests. And the cool thing about switch map is it only emits values from the most recently projected observable. So this code would have been much harder to write without RxJS. Pretty cool? Awesome. Niall's on after this talk, and he's actually doing more on RxJS. So in summary, modern web development is asynchronous. RxJS takes some effort to fully understand, but it simplifies writing async code. And RxJS is really important for you to learn because it's baked into Angular 2.
Okay, so another one of our challenges with Angular 2 is managing state. And it's not so different a design for managing state than Angular 1, and that comes with some problems. So when we started to get bigger applications, it becomes time-consuming to manage complex state management on your page. If you've got some component or several components that all need to share that same state, it becomes tricky to do. So in Angular 1, we would do things where we might jam that state into a router using UI router, but I kind of like a router that just routes and there's not a state management tool as well. We would have all that state in a service, and then would have this awkward callback system that nobody liked to be able to push out the changes to everybody else. Or we would just broadcast events everywhere. And all of these things worked, but no one agreed. It was the code I hated the most. It was the one that got refactored and disagreed about the most. And state management was awkward. And we also end up in this place where state's being changed left, right, and center. You don't know where's changing what, and you end up in this big bowl of mutable soup. And one of the things that I'm really excited about is the Redux pattern and being able to help with this problem with state management for Angular apps. So the Redux pattern is a way to implement a predictable state management container. And you can see how I'm using a little r to reference the Redux pattern, whereas a big R is the Redux library, which comes from the React community. And I'm going to just quickly run through what the basis of Redux is. So Redux all kind of revolves around this idea of having a store, a single spot where you manage all the state for your application. So it's a single JavaScript object, and it's where all of your state will go. So imagine I've got a user object. I've got to manage the state of that user across my application. I want it in the menu. I want it in the footer. And this object has an email. So I can subscribe to the store and get that state, and I can get that user object, and I can get its email and put it in the view. What I'd normally want to do is, if I update that email, is I'll just grab it in my component or my controller, and I'll just update it on the spot. But Redux is a bit different. What I'll do is I'll dispatch an action. So I'd dispatch an action, and these are the particular words that Redux pattern would use. And this action would say, can you update that email on the user? And the only place where you change state, because states are mutable, is in these special functions called reducers. So the reducer would take the user object with the email information we want to change, make a new user object, and update the email on that. And then that would flow through to the store, so the state in the store is updated. And because we're observing that and it's flowing in a one-way direction, then that state flows down into our views. So if we take this Redux pattern and we combine it onto what Steve-O's been talking about with RxJS, and we make a library that's specifically for Angular 2, we end up with something called NGRX. So NGRX is a new library that supercharges the Redux pattern with RxJS. So that's the big key differentiator between Redux and NGRX. So NGRX is a tool that will revolutionize the way you do development and your applications as well. And this is a pretty audacious statement to make, but so far it's pretty true. It's interesting. Most people who start using this go, oh my God, you know, it's such a different way of thinking. It's such a different way of writing my code, but it's so much simpler. And I can't believe it's something I'm learning now. That was definitely my experience because I've only started learning this in the last few months of using NGRX. So I've got a quick demonstration of what it would look like. So imagine you've got a music store. Here we've got an albums list page. I've got 4 albums on the page. And at the bottom here, I've got this recently viewed items. So if I wanted to get the state for that recently viewed items, I just have to ask the store because the store's got the state that I want. And anywhere else in my application can go get that same state from the store. So my code would look like this. I'd say this.viewedItems equals this.store.select viewed items. Pretty simple. And anyone else who wants it will get the exact same state just by doing the same thing. So it becomes pretty easy to share around your application, your state. So then down here, my recently views, because I'm subscribing to it, because it's an RxJS observable, I'm going to then have my single viewed item so far. But let's say I go look at another album. I want to go look at the Men at Work album. So I navigate over to that page. When I navigate there, I can dispatch an action. So it's all about going, hey, store, can I have some information? Can I have my state? And hey, store, can I dispatch an action so you update? So I'd say this.store.dispatch, and I'd pass it an object with 2 things on it. One is the action I want to take. Here it's called type, and the payload of what I want to update. So here I'm dispatching an add viewed item action, and then I'm going to pass it the album so it'll update the state of the viewed items with this album we're looking at. Pretty simple. And that's the beauty of NGRX. So because it's an observable, I'm subscribing, it'll just get updated straight away, or anywhere else on the page that's subscribing to will also get updated. So now I'll have 2 albums on the page. Now I can hear you probably all thinking right now, but where do I persist this to my database? So you've got a couple of options here. You could say, what I'll do is I'll not dispatch, but I'll persist this information to my database, and then on a successful callback from my database to say that it's got that data, then I'll dispatch this action. So that's one option. So you update your database, then you dispatch the action. The other option is you could say, I want a more responsive UI. I'll dispatch the action to the store so my state's updated straight away, and then I'll update my database. And if it fails, then I'll roll back the store, because this is one of the benefits. You can roll back and forward really easy because you've got all your state in one place. And everything listening to it will roll back as well. So it's pretty cool stuff. And there's some pros and cons to using it. So we'll roll through some of these now. Much easier state management. I think you've seen that. You've got all this pretty cool tooling around it. You've got time travel debugging. You know, you can do undo and redo functionality, really trivial. It's much simpler to build and rationalize about your application. Performance can become much better because you're passing off some of your kind of change detection to observables. So you can say, hey, Angular, can you use a different change detection strategy called onPush and just skip this part of my component tree? Don't check that. I've got it covered so things can get faster. It's much easier to test. These reducers, which is the only place you change state, so it changes your testing strategy, are pure functions. They take in a user object, they pass out a user object. They don't have a HTTP, they don't have all your injected services that you're doing in your component, so you don't have to mock all these and put them into your unit test. All you have to test is that email has changed and did it change correctly. So unit testing becomes a real pleasure for your front end. And it's getting a lot of traction. It's really interesting. You know, our project that we've just started at the moment is using NGRX. The big project that I'm mentioning for these 34-inch monitors in the last 2 months has picked up NGRX, and 2 other really big applications that my mates have got running outside of us have moved into doing it in the last couple of months. So it's really interesting watching the traction. These bigger applications were all kind of merging towards going, let's actually pick up some of the stuff from the React community. Let's start having a better state management kind of story. So why would you not want to use it? It's another dependency. It's another thing you've got to learn, and there's a lot to learn in Angular 2. It might be overkill for a simple application. If you don't have much state to manage on your page and you're happy just to post back and get that state again and you're not sharing it around, you know, you might not want to use NGRX for it. And you're all in with RxJS. That's probably the big deal. So you're going to be jumping into RxJS. You're going to be doing a lot more work with streams and all the operators that you saw Adam show you. And the way that you compose your applications and the way you structure your state is going to change. So your application structure will look very different. And I think for the positive.
Does it help in offline activity as well, like the store, using that store that can be used as
Absolutely will help. But there's a deeper story, and we'll come if you want to ask.
We're really close on time, so we might, if we can take the questions after, that would be awesome.
But the answer is yes.
Yep.
So I really like this quote from my mate Stephen, who's on the Angular team, and he says, maybe it's not an if, but a when. So not if people should use it, but when do their applications get big enough and more complex that they should start looking at using it. So in summary, for observables, RxJS and Redux, we think you should invest the time to learn RxJS. Don't just let it sit in the background of your Angular 2 applications and not use it. It's quite powerful and will help you out in many ways. We think Redux is great, but we think NGRX is amazing. And we think you should be considering using it for your bigger applications that are going to have more complex state.
Cool. So where to from here? So I'm just going to point out, so this is the agenda for our 6-week online bootcamp. And the interesting thing to notice here is that we cover all the basics of Angular 2 in the first 3 weeks. And this is really important to notice about Angular 2, is that Angular 2 is easy to learn, but there's a lot of complexity around learning the best ways to do modern web development. So in the second half of the course is where we cover Angular CLI and Material 2, doing payments, authentication, how to do testing, and then how to do Redux and NGRX. So we'll be around outside if you want to come and have a chat about that. But it's a really interesting indication of where the complexity lies in modern web development. So in summary, we had a look at what is Angular 2 and why you should care about it, and what are the different options for frameworks. We talked about how important it is to get your head around module loaders and build systems. We talked about IDEs and IDE choice and TypeScript. The challenges that are currently around CSS frameworks and widgets. And then hopefully we've helped you get over the learning hump a bit with observables, RxJS and Redux. Now, we've actually published a book. So if you're interested in getting a copy of our little book of Angular 2, come up afterwards and have a chat. And we're going to be outside here at the SSW stand if you want to come and ask us any questions. But thank you very much for coming and learning about Angular 2. You'll see us around the conference. Come and say hi.
Thanks, guys.